Hello everybody out there. Hope you guys are doing well. We've got a YouTube video today on quadratic equations and using the discriminant. So we'll talk first of all about what the discriminant is and then why there's such a level of importance to it. First thing I want you to consider and remember is when we graphed our quadratic equations earlier in this chapter. Grading these things earlier in the chapter, we were really focusing on x-intercepts. And our quadratic equations, our parabolas, there were three scenarios. There was when we had two x-intercepts, one x-intercept, or zero x-intercepts. So let's take a look at how that works and how we can then make some predictions ahead of time about what that might look like. So let's go ahead and turn on the background here. And let's shrink this up here into the corner. And let's go to the document camera. So if we go over to the document camera, we start talking about using the discriminant. The first thing I want to talk about before we even address what the discriminant is this idea of solutions or zeros or roots or x-intercepts. If we go back to earlier in this section, we know that all four of those things mean the same thing. If we are solving it algebraically, x equals blank, that's our solution. The zeros, well, the zeros are significant because that's where it crosses the x-axis. This is where y equals 0. And then obviously that follows right into x-intercepts, and the idea of a root is going to have to do with the square root, which is what's going to apply to us today. So when we graphed these parabolas and we had our quadratics, there were three situations that would take place. Your traditional parabola would do this. And it would cross the x-axis here and here. So this one would have two solutions, or two zeros, or two roots, or two x-intercepts. And then we had a situation where the vertex was on the x-axis, and therefore it only hit the x-axis once. So there was one solution, or zero, or root, or x-intercept. And then if the parabola was above the x-axis and opened upwards, then we had zero solutions. So I want us to revisit and to go back to that idea, because that idea is now going to follow with our discriminant and the quadratic formula. So we're now going to follow up and we're going to review the quadratic formula. So the quadratic formula was x equals the opposite of b plus or minus b squared minus 4ac all over 2a. So this is our quadratic formula. Now this piece right here, that is significant. That is the discriminant. The discriminant is the b squared minus 4ac, or the portion that is underneath the radical. Now this is really significant because of what is in front of the radical. In front of the radical, we have a plus or minus. Okay, and if you remember when we solved these algebraically, when we put the square root symbol in, we would get that plus or minus. Well, the significant to that is what we get inside the radical will determine if we have two solutions, one solution, or no solutions. And that's because the plus or minus symbol in front of the radical will determine that for us. So when we are using the discriminant, we have three scenarios. The discriminant equals a positive number. If it equals a positive number, that means inside the radical, we're going to have a positive number, which means I'm going to have plus or minus the square root of whatever is in there. If the discriminant is positive, we will have two solutions, or this up here, where the parabola crosses the x-axis twice. And that's because the plus or minus, a positive number, results in two answers. Now we can have the b squared minus 4ac equal 0. Now that would put a 0 inside the radical. Well, this is significant because if I go plus or minus 0, it's the same thing. So if 0 is the discriminant, therefore 0 is in the radical, that's going to give me one solution. And if I graphed it, it would look like this one here. Well, the last option I have is negative. If the discriminant, the b squared minus 4ac, or the number under the radical is negative, we're going to get 0 solutions. And that's because we cannot take the square root of a negative number. So if we have a negative number in there, we cannot finish that problem. Therefore, we have no solutions, and your graph would look like this. So let's take a look at how that's going to play out in tonight's homework. If I give you an example, and that example is 2x squared plus 10x plus 11 equals 0. The important part is that I have the quadratic set equal to 0. Now, if I want to find out what the solutions are, I'm going to plug it in to the entire quadratic formula, and I will get my two answers. But what I want to find out is, and the vocabulary for this assignment is going to ask you for the nature of the roots. That basically wants you to determine, will there be two solutions, one solution, or 0 solutions? So let's simply use the discriminant of b squared minus 4ac to find out how many solutions we will get, or the nature of those roots. Well, b squared, my b is 10, so that's 10 squared, minus 4 times a, which is 2, times 11. Okay, so we're going to simplify that to 100 minus 88, which is 12. Now, if I look at that, 12 is positive. Therefore, there will be two roots to this problem. Now, using the discriminant doesn't tell me what the solutions are. It just tells me how many there will be. So if it asks you if there are solutions or if there are roots to find them, then we will finish by plugging into the entire quadratic formula. So we'll write the whole entire formula down, and we will then go ahead and find out what those two solutions might be. Well, opposite of b will be negative 10, plus or minus the square root, and I'm going to go ahead and put 12 in there because I already know what it is, all over 2a, which is 2 times 2. So I'm going to simplify that, and I'm going to get negative 10 plus or minus. 12 has a perfect square in it of 4, and the square root of 4 is 2. Radical 3, all over 4. And I'll go ahead and reduce the 10, the 2, and the 4, because all three of them can reduce. So I get negative 5 plus or minus the square root of 3, all over 2. Those would be the two roots, or the two solutions, if I needed to find them. So a majority of your homework is just going to ask you to find how many roots there would be, or the nature of the roots. If it asks you to finish, then you have to go ahead and finish, and there is a section of homework that will do that. Let's take a look at one other example. So if I look here, and I give you 3x squared plus 4x equals negative 2. The first thing about this example is not set equal to 0. So before I can find out the nature of the roots, I have to set it equal to 0. So I'm going to add 2 to both sides. So I get 3x squared plus 4x plus 2 equals 0. I do not want to finish. I just want to know if I can finish, how many solutions there would be. So I'm going to consider the discriminant, which is b squared minus 4ac. B squared is going to give me what? It's going to give me 4 squared minus 4 times a, which is 3, times c, which is 2. 4 squared is 16. 4 times 3 times 2 is going to give me minus 24. And I get negative 8 for my discriminant. If the discriminant is negative, that means in the radical I would have negative 8. Well, I cannot have a negative number in the radical, so I'm going to have no solutions or no real roots. And we say real because we will talk about imaginary numbers when we get to Algebra 2. So we go back here just to recap. The discriminant is the portion inside the radical from the quadratic formula. If the discriminant is positive, there's 2 solutions or roots. If the discriminant is 0, there's 1 solution or root. And if the discriminant is negative, there are going to be 0 solutions. And those ideas follow up to match the graphs we talked about earlier in this unit. So if it asks for how many roots or the nature of the roots, you're simply going to plug into the discriminant to find out. And if it wants you to finish and actually give me those solutions, then you're going to finish plugging into the quadratic formula to get your final answer. I hope this video helps when it comes to the nature of the roots as well as using the discriminant. You guys have a wonderful day and take care.